this is the place to see Northern Lights.
Wow, it's like the best New Year's ever, because you're like winter time and you don't expect that everybody's out. Everybody's there on the streets, like, and have the fair and show and music. We really thought that it was like, wow, that's really amazing. Anchorage has good food, good restaurants, all the people around us friendly. We came to Anchorage to chase the aurora.
We got this 4-day package. We saw auroras every single day.
There's no words to describe. This is the place to come. Anchorage is the place to come to see the Northern Lights. Like, really, definitely.
Come to Anchorage, enjoy it. During summer, winter, whenever. Yeah. Winter is beautiful, beautiful here.
Good afternoon, everyone. Welcome to today's IEEE-USA webinar, Consultants in AI. I'm your host, Jonathan Cho. This webinar is proudly sponsored by Visit Anchorage. Please note that today's presenters are not affiliated with Visit Anchorage, and the views and content shared during the presentation are entirely their own. We're joined today by members of the IEEE-USA Consultants Committee, who will be leading our discussion. Liang Ji Downey will be kicking off the session, followed by Mohammed Baloo, Chair of the IEEE-USA Consultants Committee. Then we'll hear from Dr. Robert Peruzzi, and finally, Will Kassenbaum, PE, will wrap things up. If you have any questions during the presentation, please feel free to drop them in the live chat. We'll be monitoring it throughout the presentation. Without further ado, I will now pass it off to our first guest. Welcome, Liang. We're very excited for what you have in store for our audience today.
Good morning. Actually, good afternoon, everybody. I'm so excited and honored to join this Consultants and AI talk. And really, it's a great moment for the AI, for our electrical engineer and consultants network community. So a little bit about me, and you probably, for those of you who haven't got a chance to read through the bio from the meeting invite, my evening job, I am IEEE senior member, IEEE Region 4 Professional Development Chair. And I hold other roles such as active in Women in Engineering, is our regional coordinator, and now I'm running the regional committee, and also a member from the IEEE Energy Policy Committee. That's my evening job, and I love to work with IEEE. My day job, I am IBB. What does IBB stand for? Industry Black Belts. So it's a designation for the skills and recognition, for what we do. So I am a power utility industry black belt within Microsoft's power utility industry sector. So my talk is going to be talking about primarily the applications of AI in the energy industry. Next slide, please. So begin with a brief history review and the capability of the AI. And I'm going to share with you a library of the use cases for the energy industry, and then dive deeper into a few examples of the use cases. And of course, finally share with what I believe is the takeaway that I will leave for you. So let's look at the AI history. Next slide, please. We are entering a new moment for AI ever since 2021. The GPT, the OpenAI GPT, took the industry, the world, as a matter of fact, by surprise, right? So we're living in that continuous excitement, concerns, and depending on the type of personality you are, with the opportunities and risks generated by such momentum. When you think about the GPT and the generative AI, from what we talked about, the last one, generative AI, from this chart, what I'm trying to say, convey the message, is this AI is not something new. It's something we talked about in the research community, engineering committee, 70 years ago, in the 50s and in the 50s and 60s and 70s, right? And a long time in the making from where we're seeing today, and today and into the future. So it's not something new. But why now? Why 2021, I'm sorry. So I believe there's two factors contributed to the revolution that we see of the GPT moment, right? One is the availability of parallel processing, hyperscalers and high performance compute offered by the cloud computing phenomenon, right? Make it possible to do parallel processing, number one. The second factor is the availability of generated data, especially through the internet, right? The internet helped propelled providing, such abundance of sea of data to allow the GPT model to be trained and progress to where we are today. So the second point I want to share on this chart, you see, artificial intelligence on the three squares on the left-hand side, machine learning and deep learning and generative AI. Are they all the same thing or related? People use these terms interchangeably, right? Are they the same or one depending on the other? So in my understanding, I'm thinking, machine learning, begin with machine learning, is really, sense and response, meaning you see some data and here's the pattern of the data. And it really sense and response and data and pattern, it really represent, on the human brain, we say artificial versus real, right? Human brain, the backside of our brain function, right? It is really annotated as the reptilian brain, right? So when you have multiple machine learnings together, and that, gets evolved into the stage of artificial intelligence, which is, representing the central brain function. And people call that an hippocampus area, right? And with the artificial intelligence and many machine learning from the different aspect, you develop deep learning and, gets into the prefrontal lobe, the front of our head, right? Thinking, which is reasoning and which represent the human cognition. We call that cognitive computing, right? So that's the generative AI that we're talking about today. And, the middle brain, artificial intelligence, the lower head of the brain, reptilian side of machine learning. So that's how I, interpret, understand the different, notions of the machine learning classes. Let's move on to the next slide. Okay, so the AI transformation is really for, any kind of, software development programs and APIs where we develop interface and communicate our intent to the systems and applications to get the feedback, either as values or results or publish a paper or generate results of some sort of calculation, right? So in the good old days, you think about we have to learn computer science, part of the computer science program, we have to learn how to program in languages. And beginning from, assembly languages at a very lower level of, assembly language, move accumulator A to B, remember those days, and then move on to, C, C sharp, and Fortran, and then evolving into, a Python today. Everybody knows how to program Python. And now evolving, can you imagine now we can interface with system, use natural language, spoken language, right? To communicate the intent, what we want the systems or machines to do for us. Behind is this so-called reasoning engine, is the ability to understand the user intent, come do the jobs and come back with the results that you're looking for, right? So this is the AI transformation. It's going to disrupt many programming systems. And nowadays, you don't have to learn the programming language anymore. Can you imagine that? We are living in that moment now. Let's move on to the next slide. So, and the how part, a little bit just education. This is the GPT OpenAI from the OpenAI website. What is so-called the embedding, the ability to embed as part of the large language model. Here is a quotation for introducing text and code embedding from the OpenAI. What you see is a sort of clustering, like the notions and concept on the right-hand side, represented by the green rectangular box. Basically, it's trying to explain how this language model works, right? Is really a mathematics behind language concept. Mathematics meaning represent, a concept, a notion, animals and fruits, vegetables, or action with math. We call it vectors, right? As you can see, vectors are represented, mathematically. And that's why the system, OpenAI, or LLM will be able to cluster, say, cats and wolf, what they do, or dogs and barks and cats meow, related them together much closer on the right-hand side on your screen. Whereas it knows a quarterback throw a football is quite distant from that, right? It's that basic classification of understanding when we teach, when we enter school, we learn, at classification and so forth. So in terms of this whole thing called vectorization, which is mathematically represent these concepts, use math, right? If we move on to the next slide, mathematically, this is still part of the how. And if you look at bottom right, that XYZ quadrant, right? And, 3-dimension, in the plane is XY and the 3-dimension is XYZ. And the vectors, and can you imagine, the text embedding 3, small, which is a kind of LLM model offered by OpenAI versus text embedding 3 large. You can see the amount of dimensions it represents. The small is half the size of the large in terms of vectors. We can hardly make sense of 3-dimensional, 4-dimensional, let alone thousands of dimensions to represent that concept or that notion. What it can do, this language model, is to allow smart search by clustering and similar text strings and concept to be able to predict or recommend the next set words or the next set phrases, right? And allow anomaly detection where outliers with little relateness are identified. For example, going back to the previous chart, whether a quarterback throw a football is very distant from, wolves, dogs, and cats, right? So that anomaly detection. And then measures the diversity, concept between words and concept, phrases, and the distance between that, right? And of course, classification is a learning where text strings or concept are classified by their most similar labels. So classification is very important. Is provide efficiency for human to process information, right? This is the only way we can process information faster, quicker for retrieval. Let's move on to the next slide. So the latest LLM offered is the reasoning model. The reasoning model is not only understand language, be able to comprehend, speak back, and this is the reasoning model allow generalization, deduction, abstraction, summarization, and it has the ability like a human, like human thinks, and they think before they answer. How do they think? Based on a long chain of thoughts, based on these what they call rules or cognitive thinking, right? Before they respond to users. So reasoning model really is used for complex problem solving and coding and scientific reasoning, multi-step planning for agentic workflow. So the latest model based on the test by the AI community, it has the ability or the intelligence level equivalent to a PhD student. So it is amazing to see, how AI has come along, right? Let's move on to the next slide. So a multi-model modality is talking about, I talked about, machine learning in the early slide, machine learning, artificial intelligence, and deep learning and generative AI, right? And this augment that whole argument by thinking about, multi-model. How does it able to do cognitive thinking, right? Is really not just based on one type of data to make decision, to comprehend what's said, and is really based on, represent the ability to mimic the human 5 senses, right? The ability to smell, to see, which is vision, or be able to read videos, watch videos. And, people think about the pictures, and, pictures 1,000 words, and animations about 1,000 pictures, right? And to see and to be able to hear, like hearing, understanding natural languages, text to speech and speech to text, and language translation on the spot, right? Of course, you're adding, the haptics for touch, for sensation, for smells, for taste. You're able to do a lot, far more than, the very basic natural language understanding. So what does it mean is the system will be able to comprehend by the ability to not only understand structured data. When I say structured data, is data, an example would be time series data, right? And, like, for example, you're measuring the speed of velocity of a vehicle moving on the highway is always speed at the time and next speed the next time, right? So if you can put the data in tables represented by rows and columns, they're more considered structured data. When I talked about vision and spoken language, they're unstructured data, right? So the combination of structured, unstructured, time series, more what do you call it, batch processing time series. I talked about the vehicle moving along the highway to speed. Batch could be something, you only read once a month and, get paid a salary once a month or twice a month, right? So the ability to be able to process these structured, unstructured, time-based or batch-based is the ability, is represented by the multimodality for the AI to respond. So this is just move on to the next slide, talking about a history review about the AI, coming along the long way in the making of the AI and Gen AI to today. And here is a list of the AI use cases because I'm working in the power and utility industry. I want to talk about, I'm a member of PES, Power Energy Society. So I worked at utilities. I worked on, Microsoft, and currently I'm an IBB for over, close to 6 years. So I work with, power utility companies, energy companies, right? So this is a list of the AI use case library, regardless, what area or domain you work for those work in the power utility industry, whether it's new construction for grid transmission or transmission distribution grid expansion, to absorb the more what power generated from wind and solar, from smaller modular reactors, and or from providing power to large data center. Data center is one of the large growth area for load growth for the power utility sector, which is a good problem to tackle because for years the electricity consumption has been slow growth to a certain area, has been plateaued because of the energy efficiency, right? So now utility sector seeing the growth of, like the data center, especially the AI data center, which consumes energy a multitude more than the traditional data center, right? So moving on to generation, energy trading, to transmission, distribution, and the retail sector. You can see, we're going to share this deck with you after the presentation, get into the details. What can AI assist with all these areas of transmission, generation, distribution, transmission, energy trading, and end usage. So next slide is talking about, I'm going to take a few examples and that I worked on personally. So here's an example. I am able to allow the generative AI to be able to read this diagram and this images, right? So as you can see, the images on the right-hand side representing PNID diagram. For those in the, PNID stand for piping, instrumentation, and controls, right? I'm able to let AI read this diagram, tell me what it is about. So the next slides would given the prompt, the next slide would tell me, okay, and this is a condenser, the main component from this diagram, and it does recognize is the PNID diagram with recognizing the main components and the subcomponents and subsystems from piping, from flow, from instrumentation and control. And the next slide would show the actual further deepening the dialogue to respond to the ask from the user. If the user says, use this legend, providing the legend, here's for the electrical engineer, it would be here's a diode, here's a transistor, and organized differently, right? And the PNID would have different symbols, right? To perfect, to optimize the output. This is the a sample output generated from the Gen AI or OpenAI. The next slide talks about the construct. How am I able to build such capabilities? So the art of possible, really the architectural diagram, you feed the unstructured data in this case, which is PNID diagram, engineering drawings and other notations, procedures, and manuals, right? You feed into that to the system. The system in the middle part consists of 3 models and leveraged through the Azure OpenAI services, including text embedding. I talked about text embedding, large and small models earlier, and this is using the ADA O2 model as well as GPT-4o. Now we're talking about GPT-5, right? Or 6, and AI and Azure AI searches. Because this is based on the Microsoft Azure services and through the Azure OpenAI, you're leveraging the services provided by Azure. For those of you, if you're using the Azure OpenAI, you should be able to use other AI models to your preferences, such as using, the Elon Musk, the Grok model, or Lambda model, or Google, or other, AWS Google models, right? You have access to several thousands of models to leverage. Why do we want to do that? The business or operational outcome for the, for the power utility industry is to speed up the design process for new construction, new builds, and speed up the design and catch the errors. And not only speed up the new design, but also be able to capture, digitize an existing, for example, many legacy systems or existing build, people can't even find drawings, right? And let alone digitize it, right? If we can find the old drawings, scan the old drawings, and digitize it into a database and allow the user can have intelligent query from that drawing. So the next slide, I'm getting up to my time, and here's another example of wind project development. So if I'm a wind developer, I have specification, what kind of system I need to build. I feed in the specification of my project requirement, and I need to procure wind turbine, and I have multiple system supplier to evaluate, to choose from based on performance and specification, cost benefit. I will be able to leverage the AI to pick the best vendor, supplier equipment to do my job. So this is an example. The next slide shows another example of visual anomaly detection for the power grid. So based on the drone images or helicopter survey, right? You take picture, you come back, and you'll be able to analyze if there is a bird's nest or a impact or outage situation or a rust or a crack on the power line or a burn spot, to allow operational maintenance team to be able to do preventative or fast troubleshooting based on visual anomaly detection, based on vision analysis. The next example, talking about this is O&M example, operation and maintenance. The next example is the original, design, right? Moving on to the next slide, talking about a solar panel. The next slide, please. Okay, I actually skipped, troubleshooting of transformers and similar, same concept, right? And many of these transformers and, the Westinghouse GEs are over, 100 years old, they're still operating. We can't even find the manuals, right? Nowadays, who's got the time to read thousands of pages of manuals, right? With the Gen AI, we'll be able to get to the page, the paragraph, the chapters, and to pinpoint the problem quickly. And move on to the next slide, which is the example of design and building a digital twin for building a new solar farm, right? Through the vision analysis, LiDARs, satellite imagery, I will be able to survey the terrain and the area to be able to position and orient the solar panels based on best harvesting, of solar energy and, most efficient utilization of the land. Used through the AI vision services. So finally, next slide, please. I'm wrapping it up. We talked about, natural language as the input to the systems, right? And systems or applications and program interfaces, the reasoning behind. Now with the Azure Copilot, the user will be able to communicate through prompt, through whatever natural language, English, Spanish, or whatever you're speaking, and using this interfaces through Copilot's interface, right? And low code. And the Copilot Studio is a build authoring environment, allow the user to quickly, no code, low code, business users, engineering users who don't have to learn, programming in an AI to be quickly develop an agent, or a new agent, or use the existing agent, or agent orchestration using, semantic kernel technologies. And an example is really, at the end, is really to the right is some sort of a neural networks, right, for the agents. And so you can see a Copilot control system from the user to the back end. All right, next slide, please. So I walked you through quickly the history of the AI and the evolvement into today, through the 50s and 70s and to today, right? And the capabilities in the power utility industry, the use cases. I walked you through several examples that I've worked with as the IBB, working in the power utility sectors. Hopefully, I hope I give you a glimpse of what the AI capability is. So for the audience out there listening to this presentation, and my recommendation is really looking at embracing this new capability by learning. The engineers are quick learners. We're curious people, right? We're problem solvers. We want to learn. We want to, take many courses online, in classroom. The many classes are free, offered online, LinkedIn, and many other sources, right? What you want to do, experiment with problem solving for your companies, for your volunteer works, for consulting works, and be able to show the benefits for your organization, for your customers, right? And even in the area for those, risk adverse to folks, right? To be able to identify the risk area so we can perfect the technology advancement for the benefit of humanity, which is driving the IEEE, advancing the IEEE mission, right? So that's my takeaway. And if you have any other questions or want to have detailed question about specific use cases, feel free to contact me and after the presentation. Now I'm moving on to the next speaker. Thank you.
Fantastic. Thank you so much, Liang. Folks, we will be moving on to our next presenter. Please welcome Chair of the IEEE-USA Consultants Committee, Mohammed Baloo. Welcome, Mohammed.
Hi, thank you. Thank you for the introduction. And I guess we could get started. So yeah, just a little bit about me. So the crux of my talk is really how I've used AI to streamline kind of more of the business side of things as a consultant. So a little bit about myself. I'm a solo consultant operating in New York City. I'm an embedded software engineer as my profession for my background. I run, like I said, a solo consulting company, mainly do design work involved in medical devices, consumer electronics, and also some specialty projects. Core customers include product development companies where essentially what they want to do is identify, because their goal is to really just develop a product for their client, and they want to be able to offload a lot of the embedded software work to somebody else, and that's where I come in and help them. I've also started offering some training and some teaching experiences. You can email me on the top here, or you can reach out to me on LinkedIn, connect with me, and then you can check out my GitHub as well. There's some interesting repositories I usually work on. Next slide, please. So Liang really dove deeply into how to, nicely use AI as part of on the technical side, right? Like how can AI be used to streamline a lot of different aspects of let's say the technical work that engineers typically do. My focus is really going to be more on the business side of things, right? So as an engineer, right, and I'm pretty sure most of us in this webinar can agree to is that my passion is on the technical side, right? I really love designing, writing code, testing, just implementing things. And because again, I'm an embedded software engineer, I really like harassing and bothering electrical or hardware engineers, right? But again, I'm not just only an engineer, but I'm also a consultant. And what that means is that I have to do a lot of non-technical tasks that, to be honest, I really don't like and I really don't enjoy. So any business, right, not just consulting, you have to do just the daily grind of just menial tasks that you have to run day to day. That includes a lot of marketing. So you can't really run an effective business without marketing, and marketing is one of those things where it's really not bound by any sort of time or constraints. Really, you just have to have a regular scheduled time that you allocate for marketing and try different things to see what sticks, and then the idea is that hopefully something gives you some business. Also, right, along the lines of marketing, I have to give a lot of presentations and talks and blog posts, right? I have to write blog posts, and I like the technical side of it. It's really just getting the writing part of it becomes sometimes a challenge for me, just because I don't. For me, the core thing that I want to do as an engineer, right, is solve problems. right? And documentation, right, which does include kind of blog posts, right, does become a little bit challenging. So again, right, but nonetheless, it's important, right? It falls under the entire kind of marketing umbrella, and that's essential that we need to do when we want to run a successful business, right? So these non-technical tasks are not my passion or my core expertise. And if we can go to the next slide. So what I do is I try to use AI to basically help me to use AI to offload the tasks that I don't like to do or that I'm not good at. So for example, if I want to start writing a presentation or putting together a presentation or writing a blog post, what I use AI to do is, just get me an outline going, because I have a difficulty in just getting started on a lot of these tasks. But once I've overcome that initial inertia to get started, it becomes a lot easier to finish the task, right? So whether it be writing a blog post or putting together a presentation, all I need to do is get some help writing, just writing an outline, right? Just putting together initial thoughts, and then once I have that, then I can build on top of that myself, and that becomes a pretty quick task, right? And then, copy and paste code that I've written, etc., right? That becomes pretty easy. Just taking pictures, putting that into the document or the presentation, that becomes easier. The other thing that I use also that I've learned recently, is that AI can really help me too on the technical side too, not just the non-technical side, right? So for example, like I said, I'm an embedded software engineer. So when I deliver outcomes to my clients, right, there has to be testing done with it, right? I have to make sure that the software that I deliver has been properly tested. And what I do is, because again, it's not necessarily important for me, for that particular client, that the testing be as thorough and bulletproof and robust as possible, right? So the framework that I need to use, or to be able to test all the test cases, of course the testing itself needs to be comprehensive, but the framework that I use, they don't really care about my end client. So what ends up happening is I don't need to um, necessarily put too much thought into uh, the testing framework. So what I do is I leverage AI to be able to, like, okay, I have, let's say I'm writing something in C or C++, but I want to quickly spin up, let's say, a Python framework to be able to unit test all of the business logic in my application. That's something that I use AI really heavily with. Basically, I just want to for it to spin up some frameworks, and then I can just fill in the rest of the blanks that it leaves behind with all the necessary details. I also use AI for a lot of like non-critical code, um, just to basically help me understand, or just to, again, just to speed up the process, right? Just so I can deliver more value to my clients. I use AI to essentially put together just frameworks, right? Just here's just some functions that that are titled this way, and then the high level functions themselves essentially call into these low level functions, and then all I need to do is just fulfill in the gaps for the low level functions, and then I'm off to the races. The other thing that I really I've found value in using AI is reading other people's code, right? So for example, if let's say I'm researching a device driver for Linux, right, and they're making um, obscure calls into the Linux kernel, I can basically take those functions, copy it into, let's say, Claude, and what ends up happening is I just ask it like, hey, I just want to know what this function does. It spits out like a really nice detailed explanation of what that function does, and also points me to the actual source files that I can dig deeper. And that's the important thing, right? You have to make sure that when you're using AI, that you have to have a little bit of skepticism, right? So sure, you take what you get from AI, and then you obviously you can leverage as much of it as possible, but always make sure that you're actually testing what it's spitting out, and then more likely than not, you'll have to make some tweaks to the outputs that you're getting. So, for example, in one instance, um, I forgot which tool. So it was on an an XP IMX platform, and I needed to basically, like, I'd brick the system, and I needed to reflash the entire file system and all the components, starting from the bootloader essentially. And I forgot the name of the utility that's used in on basically my PC side to be able to enter this special mode where I can flash it on the target side. And when I asked AI about it, it would actually spit out like, hey, you can use this tool to basically like um, uh, but to enter this mode. But the problem was it was giving me the tool on the target side. And so if I inadvertently just copied and pasted that without actually verifying into the final result on my PC, like it wouldn't get me anywhere because it was just telling me the wrong tool. Again, the information that it gained was valuable, but again, you always have to make sure that you're validating and verifying the results that AI gives you. And the other kind of benefit that I've discovered a lot about this is that it becomes like a great learning tool, right? Because as you're, kind of digging deeper into functions or different frameworks, right? You understand you're just getting exposed to more and more frameworks and technologies out there that you're not aware of, and then that helps you just expand your knowledge, et cetera, and just makes you be just a valuable kind of engineer. And then if you go to the next slide. So this is kind of an example I'll just kind of go over some examples how I use specifically AI in some of the tasks that I run day to day. So for example, recently I ran a course on embedded Linux with QEMU. So QEMU is just an emulator that you can run an embedded Linux system. It's really valuable if you don't have hardware. So this was valuable to me because the course was remote. And I ran, and obviously, right, the students didn't have access to hardware, so I did everything in QEMU. So one of the challenges of running QEMU is that things change pretty drastically across different versions. And so the knowledge that I had of QEMU that was, let's say, a year ago was no longer relevant. So instead, what I did was I said, okay, hey, Claude, I know these are the functions, right, that I used previously to, let's say, set up a device or attach a device to my virtual machine. And these are obviously not the functions that I need to use in this newer version of QEMU that I'm using. What are the actual functions that I need to call? And, gave me really accurate results. But again, I went through the process, and this is important because I need to run a class, right? I can't give erroneous information in this class. So I took the output of Claude, I ran it through the build that I was running, ran the QEMU instance, verified that the device was present in Linux, and it was great. And so, in this case, I was using ChatGPT. And so, the other thing was that, like I said, like the versions were different, but nonetheless, it gave me like a great starting point to get going. So that, if I had to basically do everything from scratch, and if you're familiar with the QEMU manual, it's a really, really monstrous read, and it becomes really daunting pretty quickly. And so, AI can be just a force multiplier because it can point you to the relevant section in, let's say, a large manual that you want to be able to, if you want to pick out like a particular section that you want to focus on, but it can distill that information pretty quickly. I also use kind of ChatGPT, like I said, going, just in the previous slide, just a lot of boilerplate code. I know how to write like a Linux kernel driver, but it's a lot of kind of repetitive functions that you have to write, a lot of just repetitive code. So instead, what I did was I used ChatGPT to essentially help me create a baseline driver, and all I did was fill in the relevant functions for the device that I wanted to create. So this was kind of one technical example of how I used AI in consulting, right, in a course that I ran. If you can go to the next slide, please. And so so we have the technical side. So going back to the business side, right? One of the key things that I use AI as well is to track tasks, right? So, one of the most important thing about running a business with potentially different clients is that if you have too many clients, right, you have a bunch of different balls that you're juggling, and the worst thing that you can do is like to drop a ball, right? Because that's just unprofessional. The client thinks that you're not even considering them, and so it's just and it's just a really poor way, right? And for me, it becomes challenging if I do have multiple clients. Like, how do I effectively keep track of all the tasks that I need to do for different projects that I'm working on? And what I discovered is that I can leverage AI to effectively serve as a really powerful kind of personal assistant, right? And so what I've done is I've created like a workflow where I can record meeting notes, different forms of AI, right? Record meeting notes and then create action items from those notes, right? That AI has recorded. And what I do is I have like a relatively kind of 32-inch kind of, normal sized TV in my office. And it's just basically what it does is it's always on, right? And it just displays a list of tasks that I need to do based on the after action report from those meetings. And then, just displays it. So all I need to do is just take a quick check at that list, and I know immediately for each client, what tasks that I need to work on. And if something is if I'm falling behind on something, mentally I can, it can just trigger me to essentially focus on that task or that client for that day. And then effectively, I just mentally filter down this giant list of clients and tasks into just like, okay, these are the top 3 or 4 tasks that I need to accomplish for the day. And that's all I'm going to focus on. And so it really helps me to make sure that to streamline kind of the work that I'm doing on any given day. If you go to the next slide. And so this is kind of like a rough diagram of how I accomplish that. So I use Fireflies for my note taking. It's great because not only does it record video and audio, but it also, like I said, generates kind of action items, right, on a per speaker level. So again, it's not entirely accurate, but it's a really great starting point because it can tell me really effectively, these are the action items that I have for this particular project, right, given on this call. And then if I need to refer back to something, I can always go back to the video and the audio if I need to check something in detail. And then what I do is I have a bunch of different Zapier zaps that are set up to basically filter on these action items. So what I do is I basically take these action items, just filter for only the action items that are associated with my name, and then I pass it to another. This is not necessarily AI, but it's a tool that I use to track tasks. It's called Todoist, and then I feed them into I need to basically from Zapier, I make an API call to Todoist and then just load those into Todoist. And then what I ended up doing for the actual interface itself, because again, I'm not a web expert, all I needed to do was essentially create something that could be displayed on a web interface, right? This is an Amazon kind of Fire TV. It has a built-in browser. So I said, okay, maybe I could use ChatGPT to help me create a Node.js server that just runs on a PC on a server in my office. And then all I need to do is point the browser in my Amazon TV to that server. And it's really kind of, that's all I need, right? If you go to the next slide. Right. Sorry. If we go back one slide, and one of the kind of constraints that I wanted to say is like, so again, the important thing here also is that one thing to consider also when you're using AI for these sorts of things is that security is also an important thing. But in this particular instance, I didn't really care about security because again, this was in my office, right? My network is secure, right? So I didn't have to worry about, and it's physical, right? It's not like I'm accessing this task list from over the internet. The whole point of this workflow is that when I just come into my office, I know immediately, right? Visually, there's something there that tells me what task I need to get done for that day. So sure, you have to be considerate of, when you're developing these implementations using AI, you have to be wary of the security implications. And then, but in this case, right, I had that in the back of my mind. But when I thought about it, it's like, well, nobody's accessing my network, and I have full control of the server that's running on my PC, so not necessarily will be an issue. And that's it. I think we can go on to the next speaker. Thank you, everybody.
Fantastic. Thank you so much, Mohammed. Folks, we'll move on to our next presenter. Please welcome Dr. Robert Peruzzi. Welcome, Dr. Peruzzi.
Hello. So happy to be here. Thank you for inviting me, Daryl and John. Here's a quick bio of me. In my 20s, I was a freelance musician, and I went into the military to play music there because music business is not very good for actually making a living. And then I got tired of that. So in my 40s and 50s, I quit and I went back to school and I became a engineer. In my 40s and 50s, I was a full-time engineer and a part-time student. And then I got laid off in my 60s, and then 70s. I was a freelance engineering consultant, technical consultant, expert witness, forensic engineer, and I still do freelance music. And I will continue to perform music and do consulting until I cannot. Let's go to the next slide, please. Okay, here's my history by AI. So along came ChatGPT, and I actually had a task I needed to do. I had to generate a list of songs, and I had those songs in my memory. I knew how to play those songs, but I just had to jog my memory on a list of titles, and it failed miserably at it. So I put it away. It says, "Oh, this AI is not very good." I suppose I was using a free ChatGPT 2022 or so. I gave it another try a year later because I was behind the 8 ball to get to review a legal deposition document. So first thing I did was read the 100-page document and take notes in my usual way, and then I used ChatGPT to summarize it. Now, here's the thing about being an expert witness forensic engineer. Lawyers will shuffle the deck of their questions just to keep the person that they are deposing, to make it difficult for the deponent, the one being asked the questions. So they will ask their questions out of order. So I had AI read that deposition, 100 pages, and I had it collate the topics back into order. So every question regarding a certain topic was in one place. And then I also had it generate cross-references between the summary and the original deposition. And because I had the cross-references, it was easy to verify the integrity of the summary, and there were no hallucinations in it. Okay, the AI summary was better than mine, but I felt dirty. I never mentioned that I used it. Oh man, I felt like I was cheating. I was rather new at this, and this is in the early days of it. Let's go to the next page, please. Okay, so the next time it came from a retaining attorney. My retaining attorney requested that I review a deposition and to revise my expert report. And he made this request on a Friday night. He said it's due on Tuesday morning. I was away and I couldn't do it. So what happened was that lawyer used AI and sent me his generated summary, including the cross-references, and got it done. And I updated my report and delivered it on time. Okay, the ice is broken. It was broken by a retaining attorney. So I guess it's legitimate. I didn't feel so dirty anymore. So I began using it regularly from then on. Let's move to the next slide, please. Okay, now that the ice is broken, first of all, I always verify the output before using it as a product of my work. But I routinely use AI to, as I began, analyze depositions to reorder the Q&A from the deposition transcript. And I also analyze and summarize other legal documents, contracts, and complaints. One time I had a proposed contract from retaining attorney. He didn't want to use my agreement, and so I passed it through AI, and he says, "Oh, be careful. This is not very favorable to you." And so I went back and negotiated, and they changed that clause, and all was well. So I have a check and summarize my own expert report and other experts' reports. One time I wanted to, I submitted a paper I submitted an abstract to the National Academy of Forensic Engineers, NAFE. And I generated that abstract from a bullet list of topics which I had submitted. And then I submitted that abstract for the journal article and presentation. And bingo, it was accepted. And then I wrote the paper. And as a matter of fact, I'll be submitting, I made my presentation. I'll be submitting the, what I hope is the final draft of that article after this webinar finishes. I'm an associate editor of the NAFE Journal, and I use it to edit and critique submissions from other authors. And it does a thorough job. I'm very careful. I read the other author's article, and I make my own decisions on it, but I always pass it by AI now. Okay. I was on a case, and I noticed that in a deposition, the lawyer was beating up another expert because he did not have any background in human factors engineering. And I says, oh no, they're going to do that same thing to me. So I used AI to find a continuing education program to learn and get certified in it. Sure enough. And the way I used it was something called Coursera, Courcera. It's like the word course followed by R-A, Coursera. And now I use AI almost daily for whatever I'm feeling curious about. And just for the fun of it, just for, okay, I was curious what happens. There are some states that have laws that you have to wear a helmet while on a motorcycle, and other states you don't need to wear a helmet. I said, what's the difference on the rate of harvesting of human organs between states with helmet laws and those without? And the first thing it kind of said, you know, that's kind of rude and crass to be referring to organ harvesting. But to answer your question, yes, the rates are significantly higher for organ donation in states without helmet laws. But don't call it harvesting. So it was. I thought that was kind of curious that it was getting to me that way. So I use it almost every day. And sometimes I'll ask it silly things. I'll say, hey, I enjoy eating sardines. Do they go with peanut butter? And it says, oh, yes, they do. You can make this thing with peanut butter and a can of sardines. Then I ask it a different way. What are some things that do not pair well with sardines? And the thing it does not pair well with is peanut butter. So it contradicts itself. So you got to be careful what you get. Let's take a look at the next slide, please. So now I got a contract to survey a list of 16 patents. And I was only allowed to invoice 30 minutes for each patent. I cannot even read a patent in 30 minutes. So it's like they are implying right from the beginning that I must use, that I would have to use AI in order to answer 4 questions about each patent. I had to ask questions about, answer questions about competing technologies, prior art, if any, the likelihood of infringement, and the value of the patent. And it was kind of a tacit agreement, never even mentioned it, that a skillful use of AI was necessary. I got the job done. And what I do now, routinely, if I have something like that, I will say, look, you're not allowing me enough time to do this reading line by line. Let's get it straight right now. I am going to be using artificial intelligence to help get this job done on time and in budget for you. So anyway, the resulting of that patent survey was that it convinced the client not to waste any further effort and money pursuing that suite of patents. Let's see what's on the next page. And it looks like that's it. And I'm leaving some time for Will Kassabaum. He has a different kind of approach than mine. He definitely aimed for consulting. I kind of drifted into it when I was cut loose by my employer.
Fantastic. Thank you so much, Dr. Peruzzi. Everyone, please welcome our final speaker for today, Will Kassabaum, PE. Welcome, Will.
To the next slide. And I won't spend a lot of time since I have another 45 minutes, right, John? I'm kidding. My background is principally computer engineering from back in the day. In fact, my work at university was in artificial intelligence and those kinds of work in terms of my university study. But my work over my lifetime has been mostly in software and hardware engineering. But now these days, I'm doing a lot of power distribution with Sims Durkin Associates engineering company here in Indianapolis. And so we do a lot of water and wastewater and power studies and industrial control. So anyway, I think many of you will get copies of this. So if you need to reach out to me, you can. Next slide. So what I want to talk about here is sort of what this AI revolution does to all of us who are engineering consultants, right? In the past, all of these things were manual tools, and I would say that our company, that a lot of the work that I'm doing now is still stuck in that digital era, CAD and Excel and email and try to just kind of keep track of all those things. But obviously, everything we do is now moved to cloud files and work and all that stuff. And generative AI presents a new way of conducting a lot of that work to make it more efficient. Routine tasks that I've spent a lot of time on, whether it's contracts that I need to review and analyze, or technical responses that I need that a client is asking about. I have time to research them much more deeply and get into the nitty-gritty of what is needed to provide a responsive feedback much more quickly and sometimes much more deeply researched than it might have been otherwise, which speed things up. Next slide, please. Also, there are a number of areas here that are useful. Automation of tasks. In my case, I've been able to write a lot of scripts. I do a lot of work on a Mac, but I've been able to write a lot of scripts that can help me do things like convert documents or photos or summarize meetings, that sort of thing. Also, for contracts, I'm writing a lot of contracts. I'm doing a lot of our proposal work. So I can do a lot of review of those contracts using the AI to help me screen for the topics that my insurance provider has given me to make sure that you don't agree to something like this, Will, right? And it helps me, guides me through those things. In addition, I've written master agreements, and I need to create task orders or suggested task orders that refer to those master agreements. And sometimes I'm reformatting proposals. Also, for technical research, I'm looking for a particular component or trying to select the right thing and make sure I understand the key parts of that and the use cases. The AIs are great for digging through those details and giving me very good responses with references back to the right web pages and from the vendors of particular equipment of the technical features of those components. The other thing is project scope. Sometimes I'm just trying to make sure I don't miss anything major in a project scope, maybe when I'm writing a proposal or when I'm making a project plan. The AI can really help me create a list of those things and make sure that I haven't missed anything. And the other thing is for creating a bill of materials or something like that for cost estimation. Well, one of our typical deliverables is a cost estimate along with our electrical and mechanical designs. And so our engineers are usually filling in all those pieces, but this gives much more meat on the bones to being able to produce particular lines in that cost estimate to make sure they're well grounded and accurate. So very useful. Next slide. So here, just talking about things you can do that from automating things that go from hours to minutes, right? I've been able to develop a bunch of tools that I use. One of the things I'm working on right now, I've written about 30,000 lines of code to implement a model context protocol server wrapping QuickBooks online so that I can have a natural language conversation with my QuickBooks business data, right? So amazingly useful. And also to, check on when checks have come in, or check when, what is the statement balance I have for a particular client or customer. It's much easier to get a short synopsis of those things than having to go to QuickBooks and generate a whole report and look at the whole report and then write an email based on it or something, right? The other one thing I've been using also is when writing code, of course, it takes a lot of time. Sometimes with the AI is writing code immensely fast, but it's hard to see what all's in there. So I've got a vector database, a code index that hopefully I'll be releasing on GitHub shortly. But it's about 85,000 lines of code right now that does a beautiful job of the embeddings and things that Liang showed us earlier. It generates these embeddings for all your different code modules, including with all the different languages, carefully parses it with a tree sitter protocol, full-scale parser, and reduces it down to embeddings so it can be searched much, much faster than just grep or searching letting the AI just read the files, hunting for everything. But it's hard to manage those. It's a big, massive amount of code that can be developed much more quickly with the AI if you give it good instructions. As a software engineer, I know that typically we talk about being able to write 200 or 300 lines of code a day, properly edited, good working code. But in a matter of a month or two, I've been able to write 85,000 lines of code for this code indexer. It's just amazing. Next slide, please. So I mentioned before, one of the key things about contracts and agreement intelligence is being able to review them and get through that whole process, and also even write letters of understanding or something like that, where you're trying to come to an agreement. Typically when you have to go through attorneys and all that, which they would always advise that you do, and so I will say that too, but practically speaking, sometimes you just need to get an understanding of the deal parameters on paper so that everyone can agree, and the AI is quite good at helping you draft those things and put them together. Next slide. Technical research. So one of the things that we did recently for a client is we needed to analyze their power system. We were doing some substation work and looking at all their needs for designing future work, say for the next 5-10 years, how much they needed to grow their service. We were able to take a lot of data that we got from the power company, as well as data from their existing power service, and use the AI to help write Mathematica code to model and review and structure how all that works, right? So that we could present it in a proper way. This is work that we probably would not have done previously because it would have been too daunting. But using the AI to help generate code made it much quicker, right? And the slide talks about some other examples of using this kind of thing for selecting components, say for an IoT application. These are examples of how much the AI can help improve your your productivity. Of course, you need to watch it very carefully in what it's doing, but this should give you encouragement to try it for these purposes. Next slide, please. So I mentioned using the AI to help to develop cost estimates that we could provide. So this gives a little bit more notion of that. There's a significant reduction in the effort you have. In fact, you can even help produce the data that you need for specific components in the format you need. We use RS means, for instance, for a lot of the things that we put into our cost estimates. The AIs can generate output for the various things you need in that format to match the RS means, which can help you put together a spreadsheet that can present the information in a common and well understood format. Also, in terms of technical specifications, a lot of our specifications come from master spec derived specifications, and a lot of our work over many years. The interesting thing is I can get down into some of those specs and get into details of particular sections, and the AIs understand what the master spec sections are, and they understand what kind of things will go in there, and can help me analyze a component to get the right set of words and descriptions into the master spec format, and verify that it's accurate. Very useful. Next slide, please. So one of the things that I'm working on right now is a way to track overall project delivery requirements, make sure that I can, sort of like the set of tasks that Mohammed showed, but the same sort of thing. I'd like to, we have many projects going on simultaneously, maybe 15 or 20. And it'd be nice to be able to see in an eyeful a dashboard of exactly where we are on everything, right? This is useful, of course, for our electrical and mechanical projects, but it's even more useful when it would come to software engineering. Could tell you a lot of what all has to happen, and you can make use of the abilities of these AI tools like Claude Code and Gemini and GPT-5 and Grok 4 to help put these things together. Next slide. All right, best practices. I would suggest if you're going to try to implement this in your practice as an engineering consultant, to pick something, you know, like each of our speakers has done. Pick some things, get familiar with how they work. Maintain control. One of the things that happens is that as people make use of AI, sometimes they're not even reading what they're producing. And that is one of the biggest flaws with what this does. If it's not in your head, it's not in anybody's head. It's in the AI's potential head that may not be around anymore, right? So make sure you understand what it's producing and ask good questions. Maintain control. The AI assists, but the consultant must decide, right? Verify what you're doing. Make sure that if you don't have a sense of what is accurate, if you're an experienced consultant, you know what the answers should look like, and you should be able to look at the results and make sure that that all jives, right? The other thing you can do is try to keep track of how much effort and what you're accomplishing, and make it an estimate of what your return on your invested time and effort is, and your cost. You may be paying for some of these tools. So is this accomplishing more, as I think it does, at least for me, than otherwise? Make an estimate of that, and document your steps. One of the nice things about using these AIs too is that they can produce documentation as you go, especially for code. So make use of that so that you know what you've done at each step along the way and what kind of prompts were effective for you. And I want to mention, since this is an IEEE presentation, that IEEE has actually thought about this and produced some ethics guidance for us, right? So in particular, make sure you protect client confidentiality. If you have documents and things that are confidential to clients, if you share them with AIs, sometimes that means that they are now being used for training. Maybe your clients wouldn't appreciate that, right? The other thing is there may be situations where you're producing work product that is derived from AI outputs. In those situations, either you need to cast them completely in your own work, or you need to disclose that what you're providing is AI produced, so that there's no confusion about whether this is a human product or an AI generated product. And that's most of it. Next slide, please. That's it. Look, we're only 15 minutes long.
Fantastic. Thank you so much, Will. So everyone, I will be bringing back our guests for one final question to wrap things up. Just make sure I have everyone. All right, fantastic. So everyone, thank you all so much. So just had one final question. So as you all may know, IEEE-USA has long supported engineers in various career paths. Would any of you be able to tell us about the mission of the IEEE-USA Consultants Committee and what it aims to accomplish? And for IEEE members who are curious about consulting, what steps can they take to get involved with the Consultants Committee?
Mohammed, do you want to take that?
Sure. Yeah. So
you're our leader.
Yeah. So the IEEE-USA Consultants Committee is really geared to kind of helping streamline consultants that are out there, right, in the engineering community, specifically in the electrical engineering community. And so, like, as I said, right, there's a lot of kind of non-technical tasks that are associated with consulting, right? And so, if you've ever been interested about running a business, if you are a consultant nowadays and you want to help, you want to understand, how to avoid, kind of learning the lessons the hard way, right? We're here as a resource, right, to help you, whether it be kind of marketing. We're kind of launching some initiatives to essentially help consultants market themselves, right? Like I said, marketing is one of the biggest things in running a business. So, and it's difficult for engineers, right? Because we're not accustomed to talking about ourselves. So, we're here to help you. So, yeah, Robert.
Oh, you're muted.
Bob, you're muted. There he is.
There you go.
Oops, I did it again. If you're interested in consulting, you should look and see if there is an IEEE Consultants Network within commuting distance of you, wherever you are. And if there is, join it. It's a good experience. That was how I started out. I joined a local consultants network. If there is no local consultants network for you, contact me. I am putting together a virtual consultants network chapter. And we actually have our first kickoff meeting scheduled. I can't recall when it is, but if you contact me, I will put you on the mailing list for that. And come on, we're going to do things like learn about marketing, as Mohammed says, and what everyone knows here. It's, the three tenets or the tenets of consulting are to find a client, to reach an agreement, to please them with your work, and to get paid. And so we can talk about that over many, many meetings and have social things online too. That's all I wanted to say about that.
Oh, yes, Liang.
Okay, so MIT, I believe 3 or 4 years ago, published a paper giving the evolution of so many things in front of us, organization changes and so forth. They published a paper titled "The Future of Work is Without a Job." Google that. The future of work is without a job. Basically, what it's saying with the organizational change, especially with this whole notion, blockchain enabled, DAO, democratized, autonomous organization, DAO. Work would become a future place where, your skill would be matched with a demand, right? It's just like how car, Uber driving, the skill sets engineers will provide to solve a problem will be able to be matched with whatever. It could be a new organization, an individual asking for that skills. So joining consultant organization is a great way to leapfrog that future scenario. Basically, talking about a what do you call the gig work, right? Is coming. And, it used to be a large organization, but the organization is going to evolve. I'm going to see more and more of that, person-to-person services, whatever. It could be driving services, transportation services. It could be food services. It could be, today, residential Airbnb. I could see this evolving into professional kind of services, supply and demand, democratized. So consultant network is really looking, is a good forward-looking mechanism from IEEE to drive to be future ready. That's my comment.
Wonderful. Thank you so much, everyone. And just to let you all know, I have posted the link to the article in the comment sections of your respective live streams. I'm assuming that's the correct one, hopefully. But unfortunately, that is all the time we have for today. We know there were so many great questions from our audience that we couldn't get to due to time constraints. There's clearly a lot to explore when it comes to consulting and AI, and not nearly enough time. If you'd like to follow up with any of our presenters from the IEEE-USA Consultants Committee, feel free to reach out to them directly. We'll make sure the contact information is shared with you after the session. You can also submit your questions through the feedback survey that we'll be sending out to registrants following the webinar. Liang, Mohammed, Dr. Peruzzi, Will, thank you all so much for joining us today and providing your expert insights on how to efficiently incorporate AI into one's consulting practice. It was a pleasure having you all with us today. Thank you so much.
Thank you.
Thank you.
Bye.
And thank you to our audience for tuning in as well. A quick announcement before we close things off today. IEEE-USA's Western Caribbean cruise is just over a month away. There's still time to join us. Last-minute rooms are available. So if you've been thinking about it, now's your chance to hop aboard. Don't miss this unique opportunity to connect with fellow professionals, enjoy stunning destinations, and recharge in paradise. The booking portal link has been posted in the comment section below. If you enjoyed the content presented in today's webinar, please be sure to check out our extensive catalog of other presentations and publications available on demand on our website for your viewing pleasure. And finally, if you haven't yet, please be sure to like and subscribe to our social media channels. And don't forget to check back daily for updates on upcoming events. Have a great day, everyone.
There's cybersecurity issues, there's aging infrastructure issues, there's climate change issues that need to be solved, and I'm really excited that in my career I get to work on those types of problems. As a young professional, IEEE has given me access to opportunities to go to conferences, meet really cool people in the field, and so I think what IEEE provides is access to the larger community, and I don't know where else you would get that. IEEE is my competitive edge.